In this section, we're going to try and understand all of the different transformations that can occur to parent functions, as well as what all of those parent functions are. So we're going to start off with the equation, name, graph, domain, and range for all of the parent functions. Our first one here you should be very familiar with. It's our quadratic function. The shape of the graph is a parabola. The function is x squared. Our domain is all real numbers. The range, notice that parabola has a vertex at 0, 0, so our range goes from 0 up to infinity. Our cubic function, also known as the S-shaped graph or the snake, the function is x cubed. Our domain, again, is all real numbers, and our range is also all real numbers. Our square root function, it's half of a sideways parabola. The domain, since we can't take the square root of a negative number, our domain starts at 0 and goes up to positive infinity. And our range, because we don't get a negative as an answer for a square root, also starts at 0 and goes up to positive infinity. Our absolute value function looks like a V. Be careful when you're graphing the difference between the parabola, which has a curve, and the absolute value, which has a V. Domain is all real numbers. Range, similar to that parabola, from 0 up to infinity. Our inverse function may be new to you. 1 over x, the shape of the graph, is also called a hyperbola. Our domain, notice that we have this line that the graph approaches but never crosses. You cannot substitute 0 into the function because you would get division by 0, which is undefined. So our domain is x cannot equal 0. Similar for the range, horizontally, we've got this line in the graph, approaches but does not cross. We also can't get 0 as an answer from this function. So our range is y cannot equal 0. Inverse square, also known as the volcano function, same domain because we cannot divide by 0, and we've got that variable in the denominator. Notice that y-axis again is a line that the graph approaches but does not cross. We also have a line the graph approaches but does not cross here, but there isn't any graph below it. So our range is y is greater than 0, or from 0 to infinity in set notation. Notice I used the parentheses on this one and not the bracket because we do not get 0 as an answer from this function. And finally, everybody's favorite, our step function. Domain is all real numbers, but the range is integers only. As it's a rounding function, only integers come out of the function. First, we're going to look at the new transformations one at a time, and then in the next video, we'll put them together and look at multiple transformations of a function. On this slide, we have two different examples. These are both vertical changes to the function because they are outside, not grouped with the x. So for example, a, the parent function, is our square root. So that is the name as well as what the function looks like. The transformation, it's multiplication, so it is a stretch or a compression, and because it is not grouped with the x, it is a vertical. Any change that is grouped with the x would be a horizontal change. So this is a vertical stretch. And it's a stretch because that 3 is bigger than 1. The critical point for all of the parent functions is 0, 0. When you multiply 0, 0 by 3, you still get 0, 0. So stretches and compressions do not change the critical point of a function. And because we do not have any reflections, we're just stretching it, the domain will still be from 0 to infinity, just like the parent, along with the range. For the second example, we have the parent function is our absolute value. That is, again, the name as well as the equation of the function. The transformation is multiplication on the outside, so it is vertical, but because that 2/5 is between 0 and 1, this time it will be a vertical compression. Again, a stretch or compression does not change the critical point. The critical point will be the same as the parent function, as well as the domain and range. So our domain for the absolute value is all real numbers, and the range is from 0 to infinity. The absolute value makes all of your answers positive. Example 2, notice that both of these have multiplication grouped with the x. So this will be horizontal transformations. Our first function is our cubic function. So the parent is x cubed. The transformation is multiplication by 2 grouped with the x. What that does is, because it's in the asylum, so it doesn't act normal, you would think it's a stretch because it's greater than 1, but it's actually a horizontal compression. Stretches and compressions do not change the critical point, which is 0, 0 for all of our parent functions. It also does not change our domain, which is all real numbers, or the range. For the cubic function, it's really nice because the domain and range are all real numbers. No matter what you do to the function, the domain and range will still be all real numbers. Second example, we have our quadratic function. Inside the parentheses, grouped with the x, we have that multiplication, which is a horizontal stretch or compression. Again, it's the opposite of what you think. It looks like a compression, so that means we have a horizontal stretch. Critical point is unaffected by stretches and compressions. Domain is still all real numbers, and that range is still from 0 to positive infinity. The last piece for this video we're going to look at are the two different types of reflections. So for part A, the parent function is our cubic. And notice that multiplication by a negative is inside the parentheses grouped with the x. That means this would be a horizontal reflection. It would reflect the graph or flip it across the y-axis. Reflections do not impact that critical point. It's still multiplication. It's just by a negative this time. And because it's our cubic function, the domain and range are all real numbers, and that's unaffected by any transformation. Part B, this is our inverse square function. Notice this time that negative is not grouped with the x. So this is a vertical reflection. What that means is it will flip the graph across the x-axis. Reflections do not impact the critical point. The domain is still x cannot equal 0 because we've got that division by 0. But the range, when you think about that parent function graph, it was the volcano. So if we flip that across the x-axis, now our entire graph will be underneath the x-axis, so we will have a range from negative infinity up to 0.